nomadic pastoral system evolved on the drylands of Central Asia as an adaptation mechanism for thousands of years. Nowadays, in terms of global warming, Mongolia is becoming one of the most vulnerable countries in the world. Annual average temperature increased in Mongolia by 2.1 degrees Celsius since 1940, which is roughly 3 times higher than a global warming during the century. Climate change effects on pastoral social ecological systems of Mongolia. Glacier and permafrost melting, surface water decrease, rangeland degradation, drought and zoot increase, livestock loss, poverty increase, migration of herders from rural to urban problems, sustainability. About 10% of rivers and streams, 13% of lakes, and 15% of springs were dried out according to the 2011 Surface Water Census. Livestock loss increases during drought and zoot events. Roundtable discussion of stakeholders on adaptation of pastoral systems in Ungi, Tuing, and Badrag river basins, located in the southern part of the Kongai Mountain of Mongolia, was organized by the Ministry of Environment and Green Development. Questions discussed: how can we adapt to climate change? How can we reduce vulnerability of pastoral social ecological systems? How can we improve communication and management about drought, zoot, water, and forage in the river basins? National-level policymakers, S. Oyun, Minister of Environment and Green Development, and D. Degvadorj, Special Envoy of Climate Change in Mongolia, representatives of local government from Imog, Sum, and Bag, directors of River Basin Administration, herders, and scientists participated in the roundtable discussion. Talk of Narmandach, herder from Bayan Hongor, Imog. Upon finding out about potential zoot, which typically follows droughts, rather than lose his herds to severe zoot, herders slaughtered about 40% of his herds early winter of 2009 to 2010, stored the meat in his winter house, and sold the meat in the spring when prices are higher. Introduction of meat storage and processing facility is one important element to adapt to climate and market economic changes, was the main message for innovative adaptation of pastoral systems in Mongolia. There are few networks during drought compared to during the zoot event. It means that we need to improve drought management, especially because drought is becoming more frequent and severe due to global warming. Pastoral social ecological systems in desert steppe region is the most vulnerable compared to other ecological zones.
Long-term monitoring of permafrost has been conducted at Nahaiha and Dabat Station in Mongolia, collaborated with Keio University, National Institute for Environment Studies, and Mongolian Academy of Sciences.
Simulation model of permafrost melting had been validated with vertical profiles of measured temperature and frost distributions in the soil for 5 years. Long-term simulations for 40 years, starting from the year of 1970, indicated that surface runoff due to permafrost melting explained the general trend of measured flow rate at Ulaanbaatar Station. No runoff due to permafrost melting after 2002 is predicted, and Ulaanbaatar may face serious risk in shortage of water resources. Forest, rangeland conservation for permafrost protection in Upper Tool River watershed is critical for increasing ecosystem services of water holding capacity. Permafrost melting is producing surface runoff during March through April, which supply water to grasses for greenup. If permafrost is depleted, water supply to grasses during March to April is stopped and greenup timing is delayed until next coming precipitation on May or June.
If the greenup timing is delayed, newly born young livestock suffer severely. Drought in summer following after delay in greenup affect to the growth of livestock, and extreme weather in winter causes massive livestock loss which is called as ZOB in Mongolia. Increase in ZOB event result in poverty in rural area and increase in migration from rural area to Ulaanbaatar.
Under the circumstance of permafrost melting and increase in ZOOT events due to climate change, we present resilient adaptation to climate change in Mongolia based on scientific knowledge from APAN and active discussions among stakeholders and decision makers. Early warning system using ICT technology will provide decision support information to herders groups such as biomass distribution, snow distribution, drought condition, ZOOT prediction, meat price information, and so on. In order to avoid degradation of rangeland, it is important to control livestock numbers under carrying capacity. Economical incentive for compliance of carrying capacity is most challenging and innovative technologies are necessary. Meat freezer system with renewable energy and meat distribution management will provide economical incentive to control livestock number within carrying capacity and increase in income and job opportunity, food security, and stable society. Establishment of autonomous distributed pastoral society in terms of energy and food in rural area of Mongolia will contribute in resilient adaptation to climate change and also reducing poverty and migration from rural area to Ulaanbaatar. Government of Mongolia is just establishing river basin administrations. This roundtable discussion is a good time event for climate-compatible development strategies in Ongi, Tuin, and Badreg river basins of Mongolia. Public-private civil partnership and international collaboration is critical for adaptation and green development for Mongolia.